All right, we're going to take a look at a couple examples from Chapter 4-2, Angle Relationships and Triangles. And these may look a tad different than what you're used to. But even still, we can use previous definitions. We're going to learn some new ones, but we can use previous definitions to figure everything out that's going on in this problem. This is from problem number 9, page 227. And let's go ahead and take a look at what we already know. We've learned this before. Here we have an angle, 48 degrees, and right here we have a linear pair. So this angle right here is nothing more than the supplement of 48, so 180 minus 48 gives us 132. So I'll go ahead and write 132 in there. All right. And we also know from previous definitions that three angles of a triangle add up to 180. So this plus that is equal to 180. And we can solve for x. Say we wanted to solve for x. So nothing new. We are using all old definitions. So I'm going to go ahead and add all this up. Bleeding is equal to 180. And I just combine like terms. So I got 5x plus 135. 5x plus 135 is equal to 180. And I just subtract 135 on both sides, so that gives me 45. So 5x is equal to 45. And of course, x is equal to 9. Well, that's all whoop-de-doo. We got the algebra answer. So if we wanted to figure out what all the angles are, we would just simply put 9 in here. So that's 27 plus 1 is 28. So that's 28 degrees. And this is 18 and 20 degrees. So this plus that better equal to 180. And it does. But what else can we figure out about this? Because life isn't going to be always so simple. Well, let's take a look at this number 48. See this 48 right here? Tell me what relationship it has with that number and that number. Think on that. And let's go to the next example. Here we have problem number 19, page 227. And, oh my goodness, something changed. We don't have a 48 right here. We don't have any number right here. We have nothing, nada, zilch. There's still a couple ways we can go about this. The easy way or the hard way. Well, why do something easy when we can do it the hard way? This angle right here is the supplement of this. So that's nothing more than 180 minus 15 minus x. Do we really want to do that? Write 180 minus parentheses 15x minus 18. Remember when we did back in chapter 1, we did the supplement of an angle? That's 180 minus x. Well, this is 180 minus this right here. And we'd plug that in and add all this up and set it equal to 180. Well, there's probably an easier way to go about doing that. Let's go back to, well, let's take a look at this example again. Here we are. We have 2x and 3x. And remember, this was 132. And this angle right here, I done forgot it already, so let's take a look, was 28 and then 20. Okay? This was 28, and this was 20. And these two right here are called the remote angles. This is called an exterior angle. We'll call that exterior, all right? And these two right here equal to that. So take a look. If those two angles, these remote angles equal to this exterior angle right here, well, we might have found a property. And this is something we're going to have to explore in depth. So we have this exterior angle equal to these two remote angles. That's all we're going to do. Let's try it out. Let's see if it works. 15x minus 18 is equal to 8x plus 4. I hate the bleeding. Plus 5x. I'm going to go off the chart. There. So we're just going to add them up. So I got 13x here plus 6. And I got 15x minus 18. So we got 15x minus 18 is equal to 13x plus 6. Okay. Subtract 13x on both sides. That gives me a 2x. Add 18 to both sides. That gives me 24. And my x is equal to a whopping 12. All right, so let's say we want to find this angle right here. And we're going to just simply take our x equal 12 and plug it in right here. So 15 times 12, that's going to be 180. 180 minus 18 is equal to 162. And we had some shortcuts on this, 162. So this angle right here is 162. And its supplement, of course, is 18 because we kind of started off with 180 minus 18. We kind of knew that already. So this angle right here is 18. And I kind of wrote a little small, but there you go. And if we wanted to find the other angles, we would have just plugged 12 into there. So there's a quick introduction of the type of work that we're going to be doing in 4-2. And you can see we're going to really be expanding on triangles. So stay on top of all your definitions. All right, that's it for now.